So in the previous video, we had talked about why most quadratics don't factor, but now we want to practice factoring, so all of the examples that I will give you in this video actually work. And since we're practicing, when I give you an example, you'll want to pause the video and try to work through it yourself before watching how I solve the problem. So let me start with a relatively simple example. X squared plus 2x minus 24. So take a look at this, pause the video, and come back and see the solution. Okay, so this one clearly does not have a common factor. As soon as a is 1, we know it doesn't have a common factor. We don't have any 24 is not a perfect square. So right away, 3 of the methods are eliminated. Since a equals 1, we can use the factoring C method in this case. So before we start factoring, though, let's consider how this might break into two binomials. Since I have a negative 24 for the last term, I need to have a different signs for my binomials. So I need to have a plus and minus sign. And what this tells me right away is that I'm going to be looking at the difference of factors. The plus and minus difference of factors, and we always want the difference of the factors to give us the B term. In this case, the B term is 2, so we're looking for the difference of factors that would be 2. So we always start by writing that we could have 1 and 24 as factors, clearly not a difference of 2. We have 2 and 12, and we have 3 and 8, and 4 and 6. When we get down to that last combination, it's pretty quick to do, we realize 4 and 6 have a difference of 2, so that's what we want to work with. Now the key is we want the difference to be plus 2. So when we write this out to get our answer, we only have one option since this is 1 times x squared. X squared can only factor into x and x. So we need to figure out where to put the 6 and where to put the 4. Since we want to get a positive middle term, we want the bigger factor to go with the positive sign and the smaller factor to go with the negative sign. And you can always check your work by redistributing this. This is the correct answer, but a quick check would be first terms have a product of x squared. First term times second term has a product of minus 4x. Second times first gives me 6x. And second times second gives me minus 24. It's going to work out perfectly. So let me give you another example. This time let's consider 3x squared minus 18x plus 24. So go ahead and pause the video and come back and see the solution. Hopefully you didn't forget to check for a common factor. This is a pretty hard problem to do if you don't check for a common factor. But it's clear that 3, 18, and 24 all have 3 in common. So the first thing we want to do in solving this problem is factor out a 3. Now that would leave x squared minus 6x plus 8. So now we have a problem inside of a problem. We're going to factor what's in blue. In fact, let me just write it over here, x squared minus 6x plus 8. And let's just treat this as a separate problem. When we look at this right away, no common factors, no perfect squares, and so we're right away ready to use the factoring of C method since a equals 1. But before we do that, let's again consider the possibilities. We have, put it right up here, we're going to get a binomial out of this. Since the 8 is a positive 8, we want to consider, we have to have like signs on the two binomials. And since the difference is a minus, that means we better have a minus minus. Since it's minus and minus, it has two subtractions, we're going to look for the sum of factors, not the difference of factors. So we could have 1 and 8. That would sum to 9. That clearly does not give us the middle term. And then we would have the possibility of 2 and 4. And 2 plus 4 clearly does give us the middle term of 6. Actually, let me write that a little more clearly so it doesn't look like a 24. Okay, so if we factor it into 2 and 4, we would get the sum of 6 that we were looking for. Since both terms are negative, this would make it relatively easy to figure out. Both terms have a subtraction in the middle. So we have the first term of each factor has to be x to give us an x squared. And then we turn around and we have to put in a 2 and a 4. Note, since, as I was just saying, since they're both subtractions, we don't have to think about where to put the 2 and the 4, just place them in there. Just for a quick check, you could expand this, and first terms will have a product of x squared. First times second would be minus 4x. Second times first would be minus 2x. And the second times second gives you a plus 8. Minus 4x minus 2x does match the middle term. That's the one you have to be most careful about. And so we have completed our task, but we have to put the problem back inside of the original problem. So 3 times the quantity x minus 2 times the quantity x minus 4 gives us the answer. Mathematicians do always write the simplest factors first, especially if they're constant. So the 3 should be out front. The x minus 2 and the x minus 4 are pretty interchangeable. Okay, so let's look at another example that's slightly more complicated. 15x squared plus 2x minus 8. Okay, so pause the video and try to work it out, and then come back and see the solution. Okay, so when I'm working through this one, I would recognize that both the A and C term, first of all, there is an A that's not 1, and the A term and the C term are not perfect squares, and there are no common factors here, so I can eliminate 3 of the methods immediately. So you could, clearly, since A is not 1, you can't use our fourth method, so we can either do our factoring of A and factoring of C and guess and check, or we could go right to the AC method. I'm going to do the factoring of both in this case and show how, with a little thought, you can, you're not just blindly guessing and checking and trying all of the options. You can pick the most likely options first. So 15 factors into 1 and 15, or 3 and 5. 8 factors into 1 and 8, and 2 and 4. So first of all, there are a limited number of combinations, but if you were to try all of them, it's 2 by 2, and then you have to consider switching around all of the possibilities. So it's really, there would be 8 different combinations to try. But let me show you how we can eliminate a lot of those quickly. First of all, always it's helpful to consider what's going to be true about the signs of the two binomials, whether it's going to be an addition or subtraction. And since we have a negative 8, we have to have a plus and a minus. So right away, we know that we're going to be looking at differences to get the middle term. Now note that the middle term is has a coefficient of positive 2. The key is that that's a small number. So of the 8 combinations I could try, half of them would involve this number 15. Given that we have a 2 as the middle term, I probably want to avoid using large numbers, and 8 is relatively large as well. So I probably want to try the combinations involving 3 and 5 and 2 and 4 first. That would save us a lot of time if we only have those to worry about. So let's see what happens when we start with those. So if I start with those, I can just write 3x and 5x. I know that I'll have a difference of signs. One will be plus, one will be minus, but I want to avoid writing those in immediately because it'll be harder to switch them around later. So now we have to place the 2 and the 4. We could just do it at random and put the 2 here and the 4 here. And now what this shows us is when I go to get the middle terms is the tricky part of this, I would have a 12x, could be plus or minus depending where we put the sign, and then I'm going to have a plus or minus 10x. It's going to be the opposite of the sign on the 12x. But clearly when you put those together, we're very close to the right answer because those have a difference of 2x. The thing that we need to do now is make sure that we get a positive 2x. So we need to have a positive 12x and a minus 10x. So to make that happen, we will put a positive sign on the 4 to get the plus 12x term, and we will put a minus on the 2 to get the minus 10x, and everything will work out perfectly. Since this was a more complicated problem, you might want to turn around and just distribute this to make sure it does in fact work, but this is the solution. If we'd been a little bit less lucky and we had placed the 4 and the 2 in opposite order, we would have seen that it wouldn't work because we would have factors of 20x and 6x, and there's no way to get a difference of 2x out of that. So we would have to eliminate that possibility. So we got a little bit lucky and stumbled on the right answer right away, but we created some of our own luck by knowing that we should eliminate the 1-15 combo and the 1 and 8 combo, or at least put them on the back burner and start with the 3 and 5 and 2 and 4. So by guessing intelligently, we could get to an answer probably much more quickly than using the AC method. So let's look at one final example. In this example, I will give you 18x squared plus 69x minus 12. So go ahead and pause the video and work through this. Okay. So when you look at this, you should always first get a common factor. So let's go ahead and look for common factors. 18, 69, and 12, it may not be obvious at first, but they are all divisible by 3. So we could factor out the 3, and that would leave us with a problem inside of a problem. When you divide 3 out of 18, you get 6. When you divide 3 out of 69, you get 23. And when you divide 3 out of 12, you get 4. Okay. So in looking at this one, we have a problem inside of a problem. So let's actually write the problem inside of the problem right over here. 6x squared plus 23x minus 4. Now this has actually gotten us, just like in the last problem, down to a couple of possibilities. We have a 1 and 6, a 2 and a 3, and we have a 1 and a 4, and a 2 and a 2. In this case, I'm going to use guess and check again, but then I will go back and do this using the AC method to just make sure we have a chance to use that. We have a 6 and a 4 here, and I would note that that would give me a 24 right away. What I'm seeing is that I have a middle term of 23, which is very large. So I'm going to want to pick relative to the factors that are listed. So I want to pick factors that will get me close to that value of 23. So the 6 and the 4, if they're paired together, will give me a 24. And what's very nice is that the remaining factors are 1 and 1. So if I pair the 6 and the 4 and the 1 and the 1 together, I'll have a 24 and a 1, which is very nice for finding a 23. So I could break this down right away. I know that I want a 6x and 4 in opposite factors so that they will be multiplied together. And then that leaves x and 1 to be filled in. So I need to have a 6x and a 1x, and I need a 4 and a 1, but I wanted to get the 6 and the 4 opposite to one another. Now I need to get a minus 4 when I take the 1 times the 4, so I have to have opposite signs. But I want to get a large positive middle term, so I need to have a plus 4 that will be multiplied times the 6x to get the positive 24x. And then I will have a minus 1 times the x to bring it back down to 23x. So the solution to the problem, it is not complete here because this was a problem inside of a problem. So I would have 3 times 6x minus 1 times x plus 4. Okay. So that is the complete factoring of the original expression. Now let's just consider how we could have used the AC method to finish this problem instead, because the guess and checks can be a little bit more subtle and take a little more practice. So for the AC method, A times C would equal 24. The beauty of the AC method is if the problem can be factored, it will work. Once again, we should consider what the signs of the terms would be to determine whether we're looking for a sum or difference. To get a negative 4, I have to have, as the last term, I have to have a plus and minus, which immediately tells me that I'm looking at the difference of factors. Okay, so if I start by saying 1 and 24, I know right away I just got it. The difference of 1 and 24 is 23, so I don't need to keep going with 2 and 12 and 3 and 8 and so on. I know that I have the right possible combination in the first step. So how do I use this? With the AC method, I would rewrite the expression 6x squared plus 23x minus 4 as 6x squared. Then we need to have a plus 24x minus 1x. We need a difference that will come up to 23. That will give us 23x, I'm sorry. And then we subtract 4. So note what we did is we used the factoring of 1 and 24 to split up the middle term, and we went with positive 24 and minus 1 to get a positive 23. Now that we've done that, we can group the first two factors and group the last two factors. Now be careful, if I put parentheses here, I change my minus to a plus because we have a negative sign which will be distributed. So if I look at the first two factors, I can factor a 6x out of those two, and that would leave me with when 6x squared is divided by 6x, that leaves an x, and when 24x is divided by 6x, that would leave me with 4. And the second pair of terms can be just left as x plus 4. Now note that that's implied to be 1 times x plus 4. So there's an implied 1 right there. So what does that mean? I can take the 6x minus 1. It's almost like I'm doing a reverse distribution, and write them as a binomial, which will be multiplied by x plus 4. And once again, that came out to be exactly the same way as my guess and check method gave me. But I think it's slightly more time consuming. The beauty is you can jump right into the AC method without having to think quite as much. So you could, you don't have to sort of guess your way to the answer. It's less subtle. It always works, but sometimes if you think carefully, the guess and check method may make the problem. You might be able to solve the problem more quickly.